welcome back to Burton Math Unlocked. So as I stated, the next step that we're going to go over will be side splitter theorem. So when we have side splitter theorem, we have two triangles, one being inscribed inside of another, and every single time we have triangles like this, we automatically know that they're similar to one another, and also that we have two lines within our triangles that are going to be parallel to one another. So if we look, we have triangle ABC, and point D is on line segment AB, and E is on line segment AC, such that DE is parallel to BC. So knowing that DE is parallel to BC, I'm just going to mark this into our diagram. We also know that if we have both triangles, that there's going to be also a shared angle, which we'll get into in a second. Next part is if AD equals 12, so let's label that as 12, and DB equals 8, EC equals 10, what is the length of AC? There are three sides that we currently have labeled. I'm going to label AE as X because we don't know what that side is, even though we know that we should be solving for the entire value of AC. When we have a question like this, I personally think it's easier to see the visual, so I'm just going to split these triangles up into two triangles. So we have a smaller one, which would be triangle ADE. And then we have our larger triangle, which is triangle ABC. And within these two triangles, separating them helps us see which sides are corresponding to one another, also which angles are supposed to correspond with one another. And then it also helps us set up our proportion to solve. So before we stated that AD is 12, AE, since we don't know that length, we're just going to put X. And then AB, in order to get the length of AB, we're going to have to add the entire length of AD plus the length of DB. So 12 plus 8, and then we're going to get 20 right here. We're going to do the same thing when we're going over on the other side for AC. Some people get confused here because they're like, oh, well, there's an X. We're going to do the same operation as we did before. So since we did 12 plus 8 to get 20, we're just going to do X plus 10 and write that out. And with this information now, we can determine our corresponding sides. So we know that AD is going to correspond with AB. And then we also know that AE is going to correspond with AC. And with this information, we can start setting up our proportion to solve for X. And then from there, we can solve for line segment AC. So we have, I'm going to put green over green and then red over red, so it makes a little bit more sense. I'm going to put 12 over 20. So we put AD over AB and set that equal to AE over AC. So X over X plus 10. So I did the left side over the left side. So left side small triangle over left side large triangle, which means I need to do right side small triangle over right side large triangle. We have to make sure it stays proportional with whatever relationship we have. Of course, you can write this in many different ways as long as the sides stay proportional to one another. From here, we're going to cross multiply or butterfly method, depending on what you learned. And we're going to do 12 times X plus 10. Since X plus 10 has two terms, I'm going to put that into parentheses so it makes it easier for us to solve. So 12 parentheses X plus 10 equals 20 times X. Whenever we have parentheses like this and a value on the outside, we are going to do the distributive property. So we're going to distribute our 12 to X and then the 12 to the 10. So 12 times X is 12X plus 12 times 10, which is 120. And then equals 20 times X, which is just going to give us 20X. From here, we need to make sure that we are combining our like terms. Since there are no like terms on one given side of our equation, we're going to move like terms to a different side. So we have 12x and 20x. I'm going to move the 12x over to the side of 20x. Since 12x is positive, we're going to have to subtract it from both sides to eliminate it from the left side of our equation. And once we do that, now we're going to be left with 120 equals 8x. From here, we're going to divide both sides by 8, which you can also do in the calculator if you don't know it off the top of your head. And when we divide both sides by 8, it's because 8's being multiplied by x. So we want to do the inverse operation, which now means that 15 equals x. Now that we know that, I'm going to go back. I'm going to do a different color. I'm going to do this in red. I'm going to change all of our x values to 15 because that's what we said it was. And then now we have to reread the problem just to make sure we're solving for the right thing. Some students will answer this and say, oh, the correct answer is 15. But it's asking us to solve for the entire length of AC. So to find that entire length, we're going to have to look over here and do 15 plus 10. So 15 plus 10 is going to equal 25. So AC equals 25. I believe this question is multiple choice on the Regents for August of 23, but for the students that I teach, I made an open response just so that they can get a little bit of extra practice. Moving on to the next one, same thing, side splitter theorem, which means that we have a triangle that's inscribed inside of another. They're both going to be similar, and they're both going to have a pair of parallel sides. And I say this because it does tend to happen sometimes where it's a multiple choice question. Well, they'll show you the picture, and then you have to be able to answer what's true about the multiple choice, which it's usually going to be this triangle is similar to that triangle, or this line is parallel to that line. Oops, spelled similar wrong. Okay, same thing here. Let's read our the problem, label the sides, and then from there we can start splitting it up into two triangles so that we have a better visual diagram of what's happening. So we have the diagram below of triangle CER. LA is parallel to CR, so I'm just going to do my symbols for parallel. We know that CL is 3.5, LE is 7.5, EA is 9.5. What is the length of AR? So we're just going to label AR as X because that side isn't labeled for us. Which also tells us that once we split these up into two triangles, we have triangle ELA, so the smaller one. And then we have our larger triangle, which is going to be triangle ECR. I didn't say this in the last problem, but we do have two angle measures that we're sharing, which would be angle E. And since both triangles are similar to one another, that also means that these two angles are going to be congruent because angle measures in similar triangles are always preserved, so they always stay the same. So E would be congruent to E. So when we're trying to figure out a similarity theorem to prove that these two triangles are similar, if we know that there's already an angle that's congruent to one another, we could use side angle side similarity theorem, or we could use angle angle similarity theorem. If we had all three sides labeled for us, then we would be able to use side, 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 but we don't have that in this case. So we know that EL is 7.5. We know that EA is 9.5. Now we need to figure out the longer length, so EC. To find the full length of EC, we're going to have to add 7.5 plus 3.5, and that's going to get us 11. And we're going to do the same thing on the other side with ER. So line segment ER is going to be 9.5 plus X. So be careful not to multiply here, because we added on one side, we're going to add on the other side too. From here, all we have to do is set up our proportion. So I'm going to do the same thing as I did before. You can set your proportions up as you please, but I'm going to do EL over EC and then EA over ER. So we have 7.5 over 11 equals 9.5 over 9.5 plus X. From here we need to cross multiply, or aka butterfly method. Once again, we have two terms in our denominator for the second fraction, so I'm going to put those in parentheses when I rewrite it. So 7.5 times, so parentheses, 9.5 plus X equals 11 times 9.5. From here, we're going to distribute once again the 7.5 to the 9.5. And then we're going to distribute that 7.5 to the x. 7.5 times 9.5 is 71.25. And then 7.5 times x is 7.5x. Same thing on the other side. We're going to multiply 11 times 9.5. So you can put that into your calculators if you haven't already. And you should get 104.5. From here, we need to combine our like terms again. Since we don't have like terms on the singular side of our equation, we're going to have to move like terms. So I notice I have my constant term 71.25 and the other constant term 104.5. So we're going to move that 71.25 over to the right side of our equation. In order to do that, we have to do the inverse operation. So we're going to subtract 71.25 from both sides, since 71.25 originally was a positive number. Once we do that, our new equation is going to be 7.5x equals 33.25. To isolate x now, we have to divide both sides by our coefficient, which is 7.5. And once we do that, we know that those 7.5s cancel out. And our final answer now is x equals 4.43 repeated. Well, the last question, we didn't have any decimals, but this one we do. So we want to look back at the problem. First of all, we're solving for AR, which means that we're just solving for the value of x. And we need to round to the nearest tenth. So we're going to look at that first digit that's to the right of the decimal place, and then look next door from there. Since it's a 3, it's below 5, which means that that 4 is going to stay the same. So the length of AR is going to be 4.4. And we could say that these triangles were similar using side angle side similarity theorem if you wanted to. Okay, moving on to the next one. This is a review from one of the previous videos, and this is what we call cofunctions. So we have sine of 3x plus 3 equals cosine of 5x plus 7. When we have these two values, we know that sine and cosine are cofunctions, which also means that they need to have a sum of 90 degrees. So I'm going to just pretend like the cosine and the sine aren't there, and we're going to bring down everything in the parentheses. So 5x plus 7, and then we're going to add the 3x plus 3. And as I stated earlier, we're going to set that equal to 90. The only answer choice that matches this in this case would be answer choice 2. And that's it. Be careful not to set the two equations or the two expressions equal to one another, like in answer choice 1. We also never use 180 because the entire thing of a triangle should equal 180, but sine and cosine, since they're the two acute angles, they only add up to 90. Okay, next up. First thing I notice in this problem is that it's going to be a trig problem, so we're going to have to use SOHCAHTOA. How do we know it's trig? We have a right triangle, and then we also have an angle measure given to us. So those are two dead giveaways that help us determine if we're going to be using SOHCAHTOA or not. So I'm just going to write out SOHCAHTOA. And then from here we can read our problem. So a rock climbing wall at a local park has right triangular sections that slant towards the climber, as shown in the picture below. The height of the wall is 5 meters, and that's the height. And the slanted section begins 1.2 meters up the wall at an angle of 14 degrees. So the slanted section is usually talking about the hypotenuse whenever we see that. And then we know that there is an angle of 14 degrees, which is given to us in this problem. For some people, it's really wonky seeing this picture because it's a little slanted and distorted. So I'm just going to redraw it over on the side so it makes a little bit more sense for us. So we have this right triangle. And don't forget that 90-degree angle in the corner. And we know that this angle down here is 14 degrees. It's also telling us that the slanted section starts a little bit above this 1.2. But the entire height here is 5 meters. But that's not the entire height of our rock climbing right here, which means that we're going to have to subtract. So we're going to take our 5 meters and subtract 1.2 from it. And that's going to tell us what our final height is of our actual right triangle. So you're going to do 5 minus 1.2, and you should be getting 3.8. So this side of our triangle will just be 3.8 meters long. From here, we just need to read the problem to see what we are trying to solve for, but based off it saying the slanted height, I'm going to assume it's the hypotenuse. But let's just be sure. So determine and state the nearest hundredth, the number of meters in a length section that is slanted, so the hypotenuse. So as I stated, the hypotenuse is a side that's always going to be opposite of the 90-degree angle. So we should be able to create a straight arrow to one side, which means that this side is our hypotenuse. Also, we need to figure out the 3.8. So if we were to create a straight line from our reference angle 14 degrees, that means that this side is the opposite. Also meaning that the 3.8 is going to be our adjacent side. Since the only two sides that we're technically given are the adjacent and the hypotenuse, since we're solving for the hypotenuse, we're going to use cosine. So to set up our trig function, we're going to do cosine of our reference angle, 14 degrees, equals adjacent over hypotenuse, so 3.8 over x. From here, we need to be able to get x by itself. There's many ways you can do it. I personally just swap x and cos of 14, so that x equals 3.8 divided by cosine of 14. But if you want to show the work visually, we'll multiply both sides by x. Always by the denominator, never by the numerator. And then our new equation is x times cosine of 14 degrees equals 3.8. If you notice, x still isn't by itself, so we need to divide both sides by cosine of 14. And we're dividing because x is being multiplied by cosine of 14, so we want to do the inverse operation. Which means those two cosines of 14s will cancel out. And our new equation now would be x equals 3.8 divided by the cosine of 14. All we have to do is put this into our calculator and then make sure that we're rounding to the nearest hundredth at the end. When you start your Regents, as a reminder, the calculator that you're given is typically going to be reset. So I'm going to use my online TI-84. Same thing as your TI-84 that you get in person, and we're going to make sure that we're in degree mode. So you're going to hit mode and scroll down where you see radian and go over 1, hit enter, and then clear it out. Once we have that, now we have the necessary information for us to solve. So we have x equals 3.8 divided by cos of 14, so we're just going to type 3.8 divided by cos of 14. Beautiful. And our answer should be 3.916. And this rounded to the nearest hundredth, we're going to look at the value in the ones place and then look next door in the thousands place. Since that's a 6, we know that that one is going to round up to a 2, which means that our actual slanted height is going to be 3.92 meters. And this will be your final answer. Once again, if you didn't see my previous videos, make sure that you are circling or boxing your answer. It makes it easier for the person scoring your test. Do you have to do it? No. It's just a better visual way for whoever's scoring. If you write the correct trig function for this problem, you will receive a point. It is a 2-point question. So if you only have the correct trig equation but no other work, you can receive 1 point. If you have the correct trig equation with no errors in your work and you have the correct answer, then you get 2 points. If you only have the correct answer and no other work shown, you get 1 point. Now, if you were to have the correct trigonometric equation written, but you make 2 or more errors in your work, you receive 0 points for this question. So you want to be careful on making sure that when you are writing out the work, that you are not making any errors. If you do make one error and you follow it all the way through, so let's say you said 5 plus 3 is 7, and every other piece of work after that you still include that 7, then you can still receive 1 point. Let's try the next one. So based off of this, just looking at the figure, we know it's going to be side splitter, which means we have 2 similar triangles and then a pair of parallel sides. That's the automatic thing that you should be thinking of when we see side splitter is the 2 triangles are similar and there's 1 pair of parallel sides. Just in case the Regents tries to sneak up on you and give you one of those multiple choice questions where you have to prove why the 2 triangles are similar. It's also helpful if you have an open response question where it's telling you to state why these 2 triangles are similar as well, which is what's happening here. So we have triangle CED is shown below. Points A and B are located on sides CE and ED respectively, and then line segment AB is drawn such that AE is 3.75, AC is 5, EB is 4.5, and BD equals 6. So we just want to explain why AB is parallel to CD. So to do this, we just need to prove why the 2 triangles are similar. Once we can prove why the 2 triangles are similar, we can prove that they have 1 pair of parallel sides. So this is our small triangle, so triangle EAB, and then triangle ECD. EA is 3.75, EB is 4.5, EC, we're going to do 3.75 plus 5, so that's going to be 8.75, and then ED, we're going to do 4.5 plus 6, so that's going to give us 10.5. Okay. With this, there's many ways that you can do it. So you can try to state that there's a theorem that makes them parallel. We can do the cross multiplication method, or we can just set up a fraction and then simplify them. And if both sides equal one another for our fractions, then we are correct, which is the way that I'm going to do it here. So we have 3.75. I'm going to pick those sides that I normally choose. So EA to EC, and then EB to ED. So I'm just going to do 3.75 over 8.75. And then simplify that, and we're going to do 4.5 over 10.5. And simplify that. So take a moment if you need to put that into your calculator. And for this one, you should get a fraction, 0.42857, and then some other values. And then same thing for below. Take a moment to put that into the calculator if you haven't already. And you should be able to get the same exact answer. So 0.42857, ... Since they both equal the same thing when they're simplified, that means that these 2 triangles must be similar. And according to the side splitter theorem, we can state that these 2 triangles are similar because they have the same scale factor. Which also means that they're proportional. And once we know this, we can state that therefore, and if you don't know, these 3 dots in the shape of a triangle means therefore. So therefore, AB is parallel to CD. You don't have to do much for this problem. Your work can explain most of it. Just make sure you have a concluding statement, which would be the therefore part of what you're trying to explain. But as long as you can state that they're similar based off of them being proportional, you could also state what the actual scale factor is you'll be able to receive those credits. Next up, some of my favorite questions. People learn this by doing the distance formula. I didn't teach my class the distance formula, and some teachers will say you should have. But I do teach a lot of students who struggle to memorize formulas, so instead, we're going back to like some of the basics from 7th grade, which is rise over run, and then also doing the Pythagorean theorem, so a squared plus b squared equals c squared. And we're using that to help determine how to prove that ABCD is a parallelogram. With the way that I do it, we're going to plot the points on the graph. So we're going to use the set of axes below. So we have 0, 4. So start at 0, 0, go up 4. That's point A. We have point B, which is 3, 8. Point C, which is 8, 3. And then point D, which is 5, negative 1. Once we connect these, you're going to notice that you're creating a shape that looks like a rectangle, but it's not a rectangle. The only thing we know is that it has 4 sides, and it's apparently a parallelogram based off of what we're told in our proof. So if we look back, it says we want to prove that it is a parallelogram. So that's step 1. But we will also want to prove that it's not a rectangle. So this is a 4-point question because you're going to get 2 points from properly proving that's a parallelogram. 1 from proving it's a parallelogram, and then 1 from having a concluding statement, which would be therefore ABCD is a parallelogram. And then you're going to receive 2 points from proving that it is not a rectangle. So you're going to do that proof, and then you're going to have your concluding statement, which would be therefore ABCD is not a rectangle. And that's how you would accumulate all 4 points here. So with that, the first thing I like to write out is M of AB, which just means the slope of line segment AB, slope of line segment BC, slope of line segment CD, and then the slope of line segment AD. Once we find these slopes, that's going to help us do the Pythagorean theorem. The slopes help us determine if we have any right angles by determining if there's a negative reciprocal slope or if the slopes are the same, which means that there will be parallel sides. And then Pythagorean theorem is going to help us determine if the side lengths are congruent. So first we're going to do rise over run to get from A to B. So if we go from A to B, we're going to go up 1, 2, 3, 4. So we're rising 4, and then we're running 1, 2, 3. Both of these values are going to be positive because we're going up. Up means positive. And then we're going to the right, which also means positive. So we're going up 4 to the right 4. So our slope for AB is going to be 4 over 3. Next up, we want to find the slope of BC. So we're going to the right once again, so positive. And then we're going down this time, so it's going to be negative. So let's do our run first. So 1, 2, 3, 4, 5. And then our rise is going to be 1, 2. 1, 2, 3, 4, 5. It's going to be negative 5 because we went down 5. Remember, rise over run, not run over rise. So that negative 5 is going to come first. Over 5, which this is just going to simplify down to negative 1. Since it is a parallelogram, and we just need to prove it's a parallelogram, we automatically know that opposite sides need to be congruent and or parallel, which means that this side should also have the same dimensions, except since we're going down, it's going to be negative 4, and since we're going to the left, negative 3. Same thing over here. To get from D to A, we're going to do the same thing. So we're going to run 5, but that's a negative 5 since we're going to the left, and then rise 5. Since we're going up, it's going to be a positive 5. So our fractions are very similar. We just change the numerator from positive to negative. Same thing with the denominator from positive to negative. So since 4/3 are both positive, we're going to change both to negative, which simplifies to just 4 over 3. Same thing for AD. Since negative 5 was positive in the numerator, it changes or a negative, it's going to change to positive, and then the denominator is going to change to negative. Same thing as -1. So now that we have that, we can use these values to help us find the lengths of our sides. So we need to find this length and this length, so line segment AB and CD. They both need to be the same. So if you find one, you should automatically know the other since both slopes are the exact same. In order to do this, we would take 4 squared plus 3 squared and set it equal to c squared. And c squared is going to represent line segment AB. 4 squared is 16 plus 9 equals c squared. 16 plus 9 is 25 equals c squared, which means that we have to do the square root of both sides. So 5 equals c. 3, 4 is also a Pythagorean triple. So if you know your Pythagorean triples, then you should automatically know that if you have 3, 4, you also have the other side as being 5 for your hypotenuse, which tells us that line segment AB equals 5. If line segment AB equals 5, that also means that line segment CD will equal 5. So we're just going to go back in and label those as 5. Next up, we need to find the length of line segment BC and line segment AD. And to do so, once again, we're going to do the Pythagorean theorem. So we're going to take those side lengths. So we have 5 and -5. So 5 squared plus -5 squared equals c squared. So 25 plus 25 equals c squared. And then 50 equals c squared. And c squared represents the length of BC and the length of AD. Since we have 50 equals c squared, we need to do the square root of both sides. So then square root of 50 equals c. You want to leave it as square root. Don't turn it into a decimal because then you're going to be tempted to round. We do not want to round in these. So these opposite sides are both going to be square root of 50, square root of 50. And we're just going to write that out over in our work area. Oops. So we know that BC and AD both equal the square root of 50. From here, all we have to do is just put it all together with a few words. So we know that ABCD is a parallelogram. To prove it's a parallelogram, there's a couple of things that we can do. We can prove that opposite sides are congruent, or we can prove that opposite sides are parallel. In this case, I'm just going to state that opposite sides are congruent because we can see that we have 5, 5, and then square root of 50, square root of 50. So AB is congruent to CD, and BC is congruent to AD. And this is telling us that opposite sides are congruent. Therefore, ABCD is a parallelogram. So that would be 2 points right there. Next up, we want to prove that it's not a rectangle. So in order to prove that it is not a rectangle, we have to prove that we do not have 90-degree angles. To prove that there are no 90-degree angles, we want to prove that we do not have opposite reciprocal slopes. So no opposite / negative slopes, which was the purpose of us determining those slopes on the left. So opposite reciprocal of 4/3, or the negative reciprocal of 4/3, would be -3/4. Since we don't have -3/4 as any of our slopes, we know that these cannot create 90-degree angles. So all we will have to say is that AB, since it's not perpendicular on one side of one of those one of those adjacent sides, we automatically know that it's not going to be a rectangle because you need 4 90-degree angles. So we just need to prove that one angle isn't 90 degrees. So AB is not perpendicular to BC. And then we need to state why. Because 4/3, actually instead of saying 4/3, I'm just going to say we don't have opposite reciprocal slopes. From there, we just need our concluding statement. So therefore, ABCD is not a rectangle. And you just received your 4 points. And that's all you have to do. Like I said, if you're someone who was taught the distance formula, you can use the distance formula to help you. Just make sure that you know what is necessary to prove that something is a rectangle, a parallelogram, a rhombus, a square. Those are the main ones that typically pop up. You'll also see some that may say, prove that it is an equilateral triangle, prove that it's an isosceles triangle, or prove that it's an isosceles right triangle. You can also get questions about trapezoids. Trapezoids don't come up as often, but if you did want to prove something for trapezoid, you could just prove that the opposite sides for the top of the trapezoid and the bottom have one pair of parallel sides. Next up, we have a plane intersects a sphere, which two-dimensional shape is formed by this cross section. So if we have a sphere and you were to draw it, that was an ugly picture. You're basically just making multiple circles in your sphere, which means that our cross sections of a sphere are made up of circles. A rectangle always creates a cylinder, and then a triangle will always create a cone. On the set of axes below, we have triangle ABC and triangle DEF, and this is from January 23's Regents. And their graphs, we just need to create a sequence of rigid motions that will map ABC onto DEF. I want you to be very careful of problems like these, because there are students who are going to make the mistake of taking triangle DEF onto triangle ABC. We're not doing that. We want to make sure we take ABC onto DEF instead. So there are multiple ways that you can do this. It's completely up to you on how you want to do it. So I'm going to skip this problem, but you could do a reflection and then translate. You can do a rotation and translate. It's honestly up to what you want to do, but since there's so many different ways that can be articulated, I think it doesn't make sense necessarily to go over. But if you do have any questions, you can leave a question in the comment for me. Next up, we have another coordinate proof. So we have a triangle with vertices for the coordinates. And like I said before, I do like to use the vertices that are given to me. Oops, not a proof problem. This one is a transformation. So we have coordinates 2, 1, 0, 3, and -2, -1. So this is our beautiful triangle. From here, we want to determine and state the coordinates of the vertices of this image of the triangle after a reflection over the x-axis, followed by a translation 3 units to the right and 2 units down. So there's technically 3 transformations that we're doing here. We're doing a reflection of the x-axis, a translation 3 units to the right, and then a translation 2 units down. So to do these, we don't necessarily need the graph, but if you want to have that as a visual so you can use, you can. If you know your rules, which I'll go over here, we're going to start with our xy, which is our original points. And then from there, we're going to turn them into our reflection over the x-axis. To reflect over the x-axis, all we have to do is change our y terms to their opposites. So instead of having xy, it will be x and then the opposite of y. So if y were a positive number, like +1, it will turn to -1. If y were -2, it will change to +2. So that will be for our reflection over the x-axis. Next, we have a translation, 3 units to the right and 2 units down. If we're moving 3 units to the right, we're going to add, because we're going to the positive, so we're just going to take our x value and add 3 to it, since we're on the x-axis. And then from there, we're going 2 units down, which means that we're on the y-axis. And since we're going down, we're going negative, so we're just going to take our y values and subtract 2. So now that we have that part set up, we're just going to write out our points. So our first point is 2, 1, 0, 3, and then -2, -1. So we're just going to switch this. So our x values are going to stay the same for our reflection, and our y values, we're going to do the opposite. So we're going to have 2, -1, 0, -3, and then -2, +1. From here, we need to apply the transformations. So the going to the right 3 and then the going down 2. But we're going to do that based off of the points that we have in the middle column, not the points in the first column. So we're going to take 2 and add 3 to it to give us 5. And then -1 and subtract 2 from that, which gives us -3. So that will be our final point. And then 0 plus 3 is 3. -3 minus 2 is -5. And then lastly, -2 plus 3 is 1. And then 1 minus 2 is -1. So this will be your final answer. You can leave it like this. Just make sure you box or circle it. Or you can plot it on your graph if you want it to. Honestly, up to you. Just make sure it's clear what your final answer is. So if you were to plot on the graph, you would have something that looks similar to this. 3, 1, 2, 3, 4, 5. And then 1, -1. And you will get a straight edge for your test. So if you want it to look a little bit more perfect, just make sure you have a straight edge. Good. Moving on. We have a graph given to us. This is from January 26th Regents, so the one that was most recent besides the one that you will take tomorrow. On the set of axes below, we have triangle RST and its image triangle R prime S prime T prime are graphed. And we want to figure out the rigid motion that's going to be sufficient to prove that RST is congruent to R prime S prime T prime. First thing you want to notice is, are the letters the same distance from each other and facing each other? Because that will tell you if it's a reflection or not. So we have T to T prime, and we notice that it's 1, 2, 3, 4, 1, 2, 3, 4. The distance is 4 and 4. R to R prime, distance is 1, 2, 1, 2. And then S to S prime is 1 to 1. So since they're both the same distance and each of them are directly across from one another, we automatically know now that there is going to be a reflection occurring. So with that information, we can cancel out some of our answer choices. So we know it's not going to be a translation, and we know it's not going to be a rotation 90 degrees. So we're in between a reflection over the x-axis or reflection over the y-axis. If you notice, if we take triangle RST, and we were to fold our paper in half, we will have to fold it down the y-axis in order to get it to map on to the other side. Another way of doing these would be listing out your points. So we know the point of R, S, and T, we can determine our rule. So similar to what we did earlier, our original will always be XY. And then we want to see what's occurring to get to the next one. So R prime, S prime, and T prime. And that will tell us what type of rule we're going to use. So if it's going to be a reflection of the x-axis or a reflection over the y-axis. So we have R, which is -2, -3. We have S, which is 1, -4. And then T, which is 4, 1. And then R prime is 2, 3. Then T prime is -4, 1. And then T prime is 1, 2, 3, 4, 1. Oops, wrong one. My apologies. S prime is 1, 1, 2, 3, 4. So -1, -4. And then T prime is 1, 2, 3, 4. -4, +1. So if you notice, our x values all changed. So the -2 changed to +2, 1 changed to -1, 4 changed to -4. So we did the opposite of our x values. And then our y values, we went from something here is incorrect. My fault, I wrote a negative sign here. It's not -3, it's +3. If you were saying that while I was writing it, my apologies. So we have 3 to 3, -4 to -4, 1 to 1. So our y values stayed the same. When we change just the x values by doing the opposite of, or putting that negative sign, that means that we're doing a reflection over the y-axis. If our rule were to be similar to what we had before, which was xy to x -y, this will be a reflection over the x-axis. A way for me to remember this is that we're always going over the opposite letter. So when x is negative, we know we're reflecting over the y. When y is negative, we're reflecting over the x. So our correct answer for this one would be a reflection over our y-axis. Moving along, we have triangle ABC, which is being taken onto triangle DEF. And we're taking these on by a line of reflection. So since we have a reflection, we know there's a rigid motion, which means congruency. There's also a rotation, so another rigid motion. We want to figure out which statement is always true. In cases like these, don't look at the diagram. The diagrams are meant to confuse you. Instead, what we're going to look at is our congruency statement in a sense. So we know that triangle ABC is going to be congruent to triangle DEF. And once again, we know they're congruent because we have rigid transformations occurring. So we have a reflection and a rotation. When we have this, you can line them up to see which ones match. Or I'm just going to highlight in this sense. So we have A and D, they're both first. B and C and E are both in the middle. And then C and F are both at the end. The order matters because the order will tell us what's going to map onto what. So let's start with answer choice 1, BC, so second and last equals EF, which is true. AC equals DE. AC is first and last. DE is first and second, so that can't be true. It should say AC is congruent to DF because that's still first and last. So 1 is a possible answer choice. Then we have angle A is congruent to angle F. A is first, F is last. So this one also can't be true. It should say angle A is congruent to angle D. So we have our greens together. And then lastly, we have angle B is congruent to angle D. Angle B is second, angle D is first. So that once again can't be true. It should be angle B is congruent to angle E because they're both the blue. So our correct answer here would be answer choice 1. Next up, trigonometry. So we know it's trig once again because we have a right triangle and we're given a beautiful reference angle. So it's labeled for us, which is great. We just need to determine what side we're solving for. So let's read the problem. A man was parasailing above a lake at an angle of elevation of 32 degrees from a boat as modeled in the diagram below. If 129.5 meters of cable connected the boat to the parasail, approximately how many meters above the lake was the man? So we're trying to figure out how many meters above the lake. So we're talking about above the lake. If you're looking above, you're looking up. You're not looking to the right, you're not looking to the left. So we want to label this side as our man. So I'm going to label this as X. We're not at the bottom of our right triangle because, once again, looking above. So the side that we need to solve for is going to be labeled as our opposite. And then because it's opposite of our right angle, we know that the 129.5 is our hypotenuse. So we have SOHCAHTOA. And make sure your calculators are in degree mode. And with SOHCAHTOA, we can determine which one you're going to use. Opposite and hypotenuse would be sine. So we're going to have sine of our reference angle, sine of 32 degrees, equals x. So opposite over hypotenuse, 129.5. From here, we need to multiply both sides by our denominator to isolate x. Which means that these two will cancel out. And now we are left with 129.5 times sine of 32 degrees equals x. So once your calculator is in degree mode, we're just going to plug that in. So 129.5 times sine of 32. Yep. Oops. Okay, mine reset. Yours will not just reset on its own. It has to manually be done, so you're okay. 129.5 times sine of 32. So just put that into your calculator. Hit enter. We get 68.624. Which means that our correct answer would be 1. Last couple of problems. We have the vertices of triangle PQR have coordinates P 2, 3, Q 3, 8, and R 7, 3. Under which transformation of triangle PQR are distances and angle measures preserved? Key part here is distances and angle measures. If we have distances preserved, we automatically know it's a rigid transformation. But angle measures being preserved, it can be a dilation or a rigid transformation. So a reflection, rotation, translation. Since we want both, we automatically know it has to be congruency. So congruency will be that translation, a rotation, and or a reflection. The one that we cannot use would be a dilation. And a dilation occurs when we have multiplication or division. And or division, sorry. So we're going to look through our answer choices and see which ones have multiplication or division. And that's going to help us determine which ones can't be used. And then we'll just look at whatever's left over, and that will be the one that can be. So we have xy that's being taken on to 2x and 2y, which means that we're multiplying 2 by x and 3 times y. So that can't be true. Xy to x plus 2, and then 3y, so that's 3 times y. Can't be true. Xy being taken on to 2x, and then y plus 3. 2 is being multiplied by x, so once again can't be true. And lastly, we have x plus 2, y plus 3. Whenever we're just adding, that means that it is a translation. So we did strictly a translation here. So that's going to preserve our angle measures and our distance. Okay, last question. So we have
Side splitter theorem once again. So triangle ABC, where DE is parallel to AB. So we're just going to draw that in. CD is 15, AD is 9, and AB is 40, which is all labeled for us. We need to find the length of DE. So I'm just going to put X there. Next up, let's redraw our triangles just so we have that visual. You don't have to, but I personally like to. I think visuals are great in geometry. It does take a little bit more of extra time, but that extra time usually helps you get that extra credit that you're looking for. So 15x, we know that these two angles are going to be congruent. And then we're going to do 15 plus 9. And then we have 40 down here. So remember, whenever you see side splitter theorem, we have two similar triangles. And then we have one pair of parallel sides. From here, we're going to set it up just like normal. So I'm going to do CD, oops, highlighter. I'm going to do CD over CA, and then DE over AB. So 15 over 24 equals X over 40. We're going to cross multiply. So we get 15 times 40 equals 24 times X. We need to divide both sides by 24 to get X by itself. And then from there, we should have our correct answer, which will be 25. So 25 equals X, and that's what we're solving for here, which is going to be line segment DE. If you were to choose answer choice 1, that's because you're solving for CD. If you chose answer choice 2, that's because you're solving for CA. And I'm not really sure how you would get answer choice 4. I could figure it out. I'm pretty sure you're just doing 15 times 2, but I could be wrong. But just making sure that you're keeping your things proportional and setting it up. So once again, if you have any questions, make sure to leave a comment below. I'll be sure to answer as many as I can before the day of the test, or even if you're watching this video after the test, just in preparation of any sort of test. I'm very vigilant on top of it. Have a great day. Make sure you eat well, have a good breakfast, get a good night's sleep.